Hello students, my name is Teacher Mark. I'm your science teacher. So today we're going to study about ATM, atmospheric pressure, and mmHg means millimeter of mercury. Then we have torr, unit of pressure. Then bar, metric unit pressure. We're going to put highlights in these important matters here. Here from origin, pressure at sea level, we have 1 ATM equivalent of 100,000 and 1,325 Pascal. Then we have millimeter of mercury using barometer measurement. 1 millimeter of mercury is equal to 133.322 Pascal. Then we have torr given by owner of Torricelli, the inventor of barometer, and 1 torr equal 133.322 Pascal. Then we have bar, same order of magnitude as ATM but a decimal multiple of Pascal. So let's summary. ATM, atmospheric pressure, mmHg, millimeter of mercury, torr, unit of pressure, then bar, metric unit pressure. Now let's go to next slide. According to here, measurement of pressure, barometer, an instrument used to measure atmospheric pressure. We have 76 cm, that is the height. Then we have atmospheric pressure in this side. Let's proceed to the next slide. So here we have barometer. In this side we have vacuum. Then the height, we have 29.92 inches or 76 cm. Then because the pressure, the air pressure push the mercury, then it will go up according to the level. Here is the mercury, here is the air pressure. Barometer. Now barometer is to measure the atmospheric pressure using a mercury. It says here we have 76 cm height from here. Then the air pressure push the mercury and then the mercury going up. That is the use of barometer. Then how to measure pressure using aryanoid barometer. Here we have mercury barometer. Now let's proceed. Barometer, remember 1 ATM or 1 atmospheric pressure is equivalent of 100,000 and 1,225 Pascal. And 1 millimeter of mercury is equivalent of 133.322 Pascal. And 1 torr equal 133.322 Pascal. Here we have empty space, a vacuum, mercury, then the height, then the air pressure, which is the atmospheric pressure. Now we have a question here. If a weatherman says that atmospheric pressure is 29.12 inches of mercury, what is it in torr? Now we're going to highlight the given. The given is 29.12 inches of mercury. It says here 29, it says here, it's like this area. This area is 29.12. inches. Then write the given. So the height is 29.12 inches. Then the question is, what is the torr? Then we're going to use the solution here. Remember, 1 torr is equal to 1 millimeter. And 1 torr also is equivalent of 133.322 Pascal. So let's using a solution. Then we have (29.12 inches) in 1 inches is equivalent of 2.54 cm. Then 1 cm is equivalent of 10 millimeter. Then 1 millimeter is equivalent of 1 torr. Now we're going to cancel the inches here. Cancel the inches, cancel the cm, cancel the millimeter, and then the remaining is torr. Multiply the numbers, then the result is 739.6 torr. Now we have already the answer for torr. We're going to write 739.6 for torr. Now let's convert to Pascal. Here 1 torr is equivalent of 133.322 Pascal. Now let's cancel, and 1 torr is equivalent of 133.322 Pascal. Cancel the torr, cancel, then the result is 98,604.95 Pascal. That is how to make a solution for using a mercury barometer. Now let's have another problem here. Number 1 question is 27.7 inches of mercury. Then the question is, what is the torr and what is the Pascal? Then use the given. We have given height is 27 inches. Then torr is question. Then Pascal is question. Then let's go to formula. 2.54 cm is equivalent of 1 inches. 10 millimeter is equivalent of 1 cm. 1 torr is equivalent of 1 millimeter. 1 torr is equivalent of 133.322 Pascal. Solution. 27.7 inches. Then multiply to 2.54 cm, which is equivalent of 1 inches, multiply to 10 millimeter, which is equivalent of 1 cm, then multiply to 1 torr, which is equivalent of 1 millimeter. Then we're going to cancel the inches, cancel the cm, cancel the millimeter, and the remaining is torr. Then we have 620.48 torr. Then we need to convert to Pascal, which is 1 torr is equivalent of 133.322 Pascal. Cancel, then the answer is 82.732.63 Pascal. That is the solution of 27.7 inches of mercury. So, teacher will give you exercises here, then find the equivalent of torr and Pascal. 1, 2, 3, 4, 5 question. And then let's watch a video.
Aristotle famously said, "Nature fears of empty space," when he claimed that a true vacuum, a space devoid of matter, could not exist because the surrounding matter would immediately fill it. Fortunately, he turned out to be wrong. A vacuum is a key component of the barometer, an instrument for measuring air pressure. And because air pressure correlates to temperature, and rapid shifts in it can contribute to hurricanes, tornadoes, and other extreme weather events, a barometer is one of the most essential tools for weather forecasters and scientists alike. How does a barometer work, and how was it invented? Well, it took a while. Because the theory of Aristotle and other ancient philosophers regarding the impossibility of a vacuum seemed to hold true in everyday life, few seriously thought to question it for nearly 2,000 years, until necessity raised the issue. In the early 17th century, Italian miners faced a serious problem when they found that their pumps could not raise water more than 10.3 meters high. Some scientists of the time, including one Galileo Galilei, proposed that sucking air out of the pipe was what made water rise to replace the void, but that its force was limited and could lift no more than 10.3 meters of water. However, the idea of a vacuum existing at all was still considered controversial, and the excitement over Galileo's unorthodox theory led Gasparo Berti to conduct a simple but brilliant experiment to demonstrate that it was possible. A long tube was filled with water and placed standing in a shallow pool with both ends plugged. The bottom end of the tube was then opened and water poured out into the basin until the level of the water remaining in the tube was 10.3 meters. With a gap remaining at the top and no air having entered the tube, Berti had succeeded in directly creating a stable vacuum. But even though the possibility of a vacuum had been demonstrated, not everyone was satisfied with Galileo's idea that this empty void was exerting some mysterious yet finite force on the water. Evangelista Torricelli, Galileo's young pupil and friend, decided to look at the problem from a different angle. Instead of focusing on the empty space inside the tube, he asked himself what else could be influencing the water. Because the only thing in contact with the water was the air surrounding the pool, he believed the pressure from this air could be the only thing preventing the water level in the tube from dropping further. He realized that the experiment was not only a tool to create a vacuum, but operated as a balance between the atmospheric pressure on the water outside the tube and the pressure from the water column inside the tube. The water level in the tube decreases until the two pressures are equal, which just happens to be when the water is at 10.3 meters. This idea was not easily accepted, as Galileo and others had traditionally thought that atmospheric air has no weight and exerts no pressure. Torricelli decided to repeat Berti's experiment with mercury instead of water. Because mercury was denser, it fell farther than the water, and the mercury column stood only about 76 centimeters tall. Not only did this allow Torricelli to make the instrument much more compact, it supported his idea that weight was the deciding factor. A variation on the experiment used two tubes, with one having a large bubble at the top. If Galileo's interpretation had been correct, the bigger vacuum in the second tube should have exerted more suction and lifted the mercury higher, but the level in both tubes was the same. The ultimate support for Torricelli's theory came via Blaise Pascal, who had such a mercury tube taken up a mountain and showed that the mercury level dropped as the atmospheric pressure decreased with altitude. Mercury barometers based on Torricelli's original model remained one of the most common ways to measure atmospheric pressure until 2007, when restrictions on the use of mercury due to its toxicity led to them no longer being produced in Europe. Nevertheless, Torricelli's invention, born of the willingness to question long-accepted dogmas about vacuums and the weight of air, is an outstanding example of how thinking outside of the box, or the tube, can have a heavy impact.